All right, so today we're going to be talking about data distributions. Now, with data distributions, we're going to be looking at curves of a line. We're going to be looking at how lines form and how data is distributed, okay? So we're looking at how data is distributed over a certain amount of time. So the way I've described this, and it's kind of odd, people always think this is a little weird, but what I do is I describe it using possums or armadillos or whatever you have, okay? And here I got armadillos. So with this, and you'll make sense here in a second, but we'll start with this first armadillo. Now, when you have data displayed, you're going to have a curved line. It's going to show you a set of data points. It's going to be in a curved shape. So when you look at this, armadillo, and you can do this with your pencil, all you're going to do is you're going to start down here, and you're going to see that he's going to go up, curve, and then come back down, okay? So go ahead and draw that line. Like I said, you can see he doesn't have a tail. His tail's kind of tucked up under him. So he doesn't have a tail hanging out. He's just a kind of a humped over, one hump armadillo here. So when we have that one hump being represented in a set of data, that's what we're going to call normal distribution. Normal distribution. And all that means is our data is displayed symmetrically. We would have data starting really, really high up here in the middle, and then it would be branching off of that. So then it would come down a little bit, or it may be up here kind of the same. But then you're going to have data bars that are going to come down, down, and it's going to start decreasing. Now, it may not follow the same shape, but it's pretty darn close. You're going to notice that most everything's going to be relatively similar in how it's shaped out. But you can see how your data would go up, and then it would come back down. So it's one smooth curve, one hump, and it forms in the middle when we look at that. So that's what we're going to call normal distribution. Now, you're going to have to memorize that for the test, okay? Because there will be a couple graphs, and you'll have to know the different distributions. The second type of distribution that we can have is called uniform. Now, uniform distribution is when it comes straight across. And if you notice our armadillo over here on the right, he's going to be a flat armadillo. You see how his goes straight across? So what this means is that his data, basically, all the bars come right up to the top. And you can see that when we draw the bars in here, you'll see how it all comes pretty much those straight across. That's called that's what we call uniform. Now, does every one of them have to be straight across? No. But most of them are. So when we have flat across, that's called uniform distribution. So with those two different types of distribution, you can notice a couple different things. Like I said, one's going to have a hump. If it's a one hump distribution, it's going to be normal distribution. If it's uniform distribution, it's going to be flat and straight all the way across. Go ahead and take a second and write that down if you don't have it copied down, and then you can move on to the next two. Alright, so for our next two animals, we have what we call right-tailed and left-tailed. Now, with these two armadillos, you can kind of see that the shape, it goes up really high, but then once the data gets off to the other side, it goes back down and has what we call a tail. So when it has a tail to the right, we call that skewed. Skewed right. A lot of times you'll see it either called that, or sometimes you'll see it called right-tailed. But this just means that wherever your data is, the highest part of it's to the left, but then the tail of it is to the highest part of it's to the left, but the tail of it's to the right. So with data here, you might start pretty low over here with your data, and then it'll start getting really, really high, and then it'll start coming back down. This would be an example of right-tailed. A lot of times you'll see this like in a grade book. When you're looking at grades, if somebody does really, really poorly on the test and a lot of students do really, really bad, then that means that all their grades are going to be lower. And then high grades. Right? So that would mean that that is right-tailed because the grades go, there's a lot of people that made really bad, but then when you get to the higher grades, there's fewer people that made really good. That's what we mean by skewed right. There's really, really low grades and then a few really high grades. Now, just opposite of that would be our second graph over here. And this one, you notice that it's going to be tailed over here, and it's going to come up, and then it's going to flow down. That's going to be what we call left-tailed, or skewed left. And like I said, you can write left-tailed underneath it too. So in this one, this is like the opposite. Here you're going to have like, maybe you have 2 or 3 people that score really low, right? But then your grades start to pick up, and they get higher as you go across. Then maybe a lot of people scored in the 90s, but then maybe a couple people scored in the 100s. So then you can see your graph blow up and come back down. So this is what we call skewed left. Skewed left. And this is skewed right distribution and skewed left distribution. So just 2 different types of distribution. And like I said, you base it on which way the tail is faced. All right, go ahead and take a second and write that down. If you have any questions, raise your hand and I'll come around and help. All right, the last type of distribution we have is when we have 2 humps in our data. So with this one, you're going to notice that you'll have 1, then you'll have 2, and then it'll curve back down. Kind of made my curve weird there. But it should curve back down kind of like this other side did. There we go. All right, so this is going to be called, since it's 2 humps, bimodal distribution. Bimodal distribution. And like I said, bimodal just means that you have 2 sets of data that rise really high inside of your data set. So here you would have a gradual increase of data, and then it's going to rise up to a peak, then it's going to come back down, then it's going to go back up, and then it's going to come back down. So like I said, your data will rise really, really high, roll back down, rise high again, and then come back down to a peak. So that's going to be what we call bimodal distribution. Take a second, write that one down, and then we'll be finished with our distributions, and you can turn your page over to the other side. All right, so the next topic we're going to talk about on the back is called dot plots. Now, this particular problem, it says a survey of how many or how long does it take you to eat breakfast has these results. So people that did not eat breakfast, there's 6 people. We have people that took 1 minute, 2 people, 2 minutes, 3 people, so on and so forth, right? 3, 4, 5 minutes, there was 5 people, 2 people, 5 people. And you can continue this pattern all the way down. So it says, which means that 6 people took 0 minutes to eat breakfast. They probably had no breakfast. 2 people saw that they only spent 1 minute, and etc. So it says create a dot plot using the data, and it says can we draw a histogram? So we're going to come down here to our little space, and we're going to see if we can draw these 2 different ones. So let's just split our paper in half right quick. And on one side we'll do our dot plot, the other side we'll do our histogram. So we'll just label this side dot plot and histogram. All right, so with our dot plot, that's pretty easy. All we're going to do is a number line on this. Bless you. So you'll draw a number line all the way across. And then in this case, we're going to have what we call like a constant change, which is going to be your minutes here because it's going to grow 1, 2, 3, 4. It's constantly growing by 1. But then people are going to be what you call your frequency. They're going to be moving up and down. So there's going to be different numbers of people at different places. So let's go ahead and label this by minutes. So we'll start with 0 minutes, 1 minute, 2 minutes, 3 minutes, 4 minutes, 5, 6, 7, we need to go to 12. So that would be 8, 9, 10, 11, 12. And we'll just label each one of them so that we remember which one's which. All right, so once we got those labeled, all we're going to do next is just put, it's simple, it's a dot plot. So we're just going to put dots for the number of people. So at 0 minutes, we had 6 people. So at 0, we're going to put 1 dot, 2 dots, 3 dots, 4 dots, 5 dots, 6 dots. For 1 minute, we're going to put 2 people. So at 1 minute, we're going to put 1, 2. For 2, we're going to put 3. And then for 3, we're going to put 5. And we would continue this pattern all the way across. Let's see if we can finish it out. All right, so go ahead and see if you can finish this out, and then I'll have it finished when you restart the video. All right, so for our dot plot, you should have got the following as your answer. So if you look here, we had, like we said, we had 6 people that ate 0 minutes, 2 people that ate 1 minute, 3 people that ate 2 minutes, 5 people that ate 3 minutes, 2 people that ate 4 minutes, 5 people that ate 5 minutes, 0 people who ate 6 minutes, 0 people who ate 7 minutes, 2 people that ate 8 minutes, and 3 people that ate 9, 7 people who said 10, 4 people who said 11, and then 1 person who ate 12. So you can see how we labeled it out all the way through here. Now here's the cool thing about a dot plot, okay? And even a histogram. With a dot plot, we can determine the type of data distribution. What type of data distribution is happening here? All right, 2 humps. 2 humps is called what? Bimodal. You can see how the data comes up, then it goes back down. So there's 2 humps here. So that's what we call a bimodal dot plot. Okay, so this would be bimodal. All right, so then we do the same thing with histogram, except histogram is going to be like a bar graph in some ways. Okay, so here you're going to have like an X and Y axis. And then with this one, you're going to still do the same thing. You put your constant rate of change on bottom, which here would be minutes. And then on the side, we would have our change or our frequency, which would be people. And then we would label out our time. So on minutes, we got 0 to 12. So I'm just going to mark here. So we're going to have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Looks like we need to extend our graph on that. 12. All right. And then going up, we have the highest being 10. Well, I'll take that back. The highest being 7. So that's going to be 1, 2, 3, 4, 5, 6, 7. And we need to label those. 4, 3, 2, 1. And this one, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. Now, sometimes you'll see them label them by each number. Sometimes they'll label them out like as intervals. So sometimes they'll say how many people was between 0 and 2. And then they'll put 0 to 2. And then you would count up the total number from 0 to 2. But for this one, we're just going to label each one since we have so many people. All right, so to do a histogram, first thing is you got to make sure you label your sides, put what each side represents, and then you may also want to put a title. So we'll just call this one breakfast. Now to show it here, instead of doing the dots, we're going to draw kind of like bars, but the bars are going to be connected. So here for 0 minutes, we had 6 people. So here at 0, that's what I forgot. This was supposed to be 0. Darn. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then there's 12. So go back and make that change. Sorry about that. All right, so for 0 people, we've got 6. So we would draw our bar. For 1, we would have 2. For 2, we would have 3. And all we're going to do is just draw a bar up to that number and then make sure all the bars are connected. So for 4, we would have 2. All right, so go ahead and continue doing this, and I'll show you the answer here at the end. All right, so we finished our graph, so we show our histogram. So you should notice the same thing happens here. With this one, we're going to have 2 humps, so it's also still going to be bimodal. So keep in mind that when you're dealing with a histogram, you got to make sure your bars are connected and everything is labeled. Go ahead and take a second and write this down, and then I'll show you the last 2 definitions. All right, so for your definitions, go ahead and take a second and write down each definition. And then once you understand what these say, you can then see if you can do A and B. All right, so for answer A, you should have got observational, and for answer B, experimental.